In this video, we're computing the integral of sin x times cosine x in two different ways. Those two different solution methods lead to two solutions that look totally different from each other. And we're going to finish by showing those two solutions are actually equivalent. So the first way we're going to do this is by directly using the chain rule backwards. So to illustrate what I mean, the way I'm viewing this integral is that I have the sine of x sitting right next to the derivative of the sine of x. That's the cosine of x. Well, that derivative of the interior function, so we're calling sine x the interior function here, that takes care of the chain rule, and I can immediately integrate this thing to 1/2 sine squared x. Don't forget to put a plus c on there. This is an indefinite integral. Now, if you're not comfortable with that approach, you could handle this with an explicit u substitution, and all I'm saying here is that u is sine x, and then cosine x dx, that would be du. You're going to get the same answer. Now, the second approach to this integral is that we're asked to start with the identity sine 2x is 2 sine x times cosine x. So in our integral, we have a sine x times cosine x. And turning this identity around, we should be able to express that as 1/2 times sine 2x. So the integral is transformed to a 1/2, I'll just pull that out in front, times sine 2x dx. And again, we're going to use the chain rule backwards on this thing. So I have a 1/2 out in front. That's a spectator. Now I'm trying to figure out what's the integral. And sine of 2x basically comes from negative cosine of 2x. When I differentiate that, the derivative of cosine carries a minus sign with it, so that's taken care of. But then the chain rule produces a factor of 2. So to get this just right, we need to tack on a factor of 1/2, and there's a plus c hanging around, of course. And I can combine the minus sign and the two factors of 1/2 to get negative 1/4 cosine of 2x plus c. So there's our two solutions, and they look quite a bit different. I have a squared sine function, I have a cosine of 2x. How can we figure out that these are actually saying the same thing? So in part 3, we're going to show these two antiderivatives are equivalent, and we're given a hint that the plus c plays an important role in this proof. And you have a couple choices here. You can start with the one on the left and prove it's the same as the one on the right, or vice versa. Both of them work. I'm just going to start with the one on the left, and I have a 1/2 sine squared x plus c. Now we just have to remember an identity for sine squared x, and I normally call this the power reducing identity. Sine squared is 1/2 times the quantity, 1 minus the cosine of twice the angle. And I can already see I'm getting close to that second solution. Don't forget to keep that plus c. So 1/2 times 1/2 is 1/4, and I'm going to distribute that, and I end up with 1/4 minus 1/4 cosine of 2x plus c. And here's where the arbitrary constant comes in. If c is really an arbitrary constant, then c plus 1/4 is also an arbitrary constant, and we can just give it the same name. We could just call it c. So I end up with 1/4 cosine of the quantity 2x plus c. And we've shown that our two solutions are equivalent. I feel like I've got enough space here to just show how it would go if we did it the other direction. I could start with 1/4 cosine of 2x. And this time I have to remember an identity for the cosine of 2x. And what's going on in my head here is I remember the identity for the cosine of a sum of two angles. And so the cosine of x plus x is what I'm thinking here. And it ends up producing a cosine squared of x minus a sine squared of x. And I forgot my plus c for a moment. Let's get that back in there. So what am I going for here? I'm trying to show that this is equivalent to our first solution, 1/2 sine squared plus a constant. And that cosine squared is annoying me, so I need to use a Pythagorean identity to get rid of that. Cosine squared x is going to be 1 minus sine squared x. So this is transformed to negative 1/4, 1 minus sine squared x, minus another sine squared x, plus an arbitrary constant. So I distribute the negative 1/4, and I have negative 1/4, and then I have a minus 2 sine squared x inside those parentheses, but I multiply that by negative 1/4. This gives me a positive 1/2 sine squared x plus c. And again, I use this argument that if c is an arbitrary constant, then c minus 1/4 is just some other arbitrary constant. So I can write it as 1/2 sine squared x plus c, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zax Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zax Lab, and best of luck on your math and physics journey.